We'll be looking at a few of the 10 scenarios of the paired sample t-test. To begin, let's click on the Start button. So we're going to evaluate this scenario. To retain the null, we'll click on the scenario card. Otherwise, to reject the null hypothesis, we'll click on the Reject the Null Hypothesis card. So here's our scenario. For a group, just one group of people here, we're comparing the pre-test with the post-test scores. We have 2 measurements per person. We'll calculate the difference score for each person. So for each person, we'll say pre-test minus post-test, for example. That would be the difference score. And these difference scores are fairly normally distributed. The null hypothesis is that the pre-test scores will be less than or equal to the post-test scores. We take a look at the evidence, and the pre-test scores are actually greater than the post-test scores. So that's a positive sign that we might be able to reject the null hypothesis. The pre-test was 71.8, and the post-test was 64.9. We take a look at the t-test statistic, and it's a 2.14. That's looking good. Degrees of freedom is 10, and our p-value for a two-tailed test is 0.058. Now, we're doing a one-tailed test. If this had been a two-tailed test, our null hypothesis would have been that the pre-test was equal to the post-test. That is no difference. But we're doing a one-tailed test. The null hypothesis said pre-test would be less than or equal to the post-test. So we're going to take this p-value two-tailed, and we're going to divide it in half. So that's going to come out to be 0.029. which is less than or equal to our alpha level of 0.05. Another kind of trick to keep in mind is, you notice how we're always dividing it and comparing it to 0.05? So I know that the p-value is 0.1 or less. When I divide in half, it'll be 0.05 or less. So you could do it that way. I could say, hey, that 0.058 is less than 0.1, and go with that. Or I can just do it the typical way, which is, if I'm doing one-tailed test, I divide the two-tail in half and compare it to 0.05. So we are rejecting the null hypothesis here. Okay, for our next scenario, for a single group, compare the pre-test with the post-test scores. When we calculate those difference scores, they're fairly normally distributed. The null hypothesis is that the pre-test scores are the same as the post-test scores. That is like no difference, nothing going on here. When we look at the evidence, it's a 41.4 compared to a 33.0. That's a difference. But is it a statistically significant difference? Our t-test statistic is a 2.8, 5 degrees of freedom, and the p-value for this two-tailed test is 0.031, which is less than or equal to our alpha level, so we'll go ahead and reject the null. In this next scenario, our null hypothesis is that the pre-test is equal to the post-test. Again, no difference, two-tailed test. The pre-test is a 30.7, the post-test mean is 32.9. Fairly similar. The t-test statistic is a negative 0.49. That's pretty close to 0. Degrees of freedom is 35, and the p-value for this two-tailed test is 0.629. So we're going to retain the null because that p-value is larger than our alpha level of 0.05. Okay, for this scenario, the pre-test mean is specified as being less than or equal to the post-test mean. The pre-test mean is a 76.6. The post-test mean is a 67.1. So the results here are the opposite of the null hypothesis. So it's looking good. We might be able to reject the null. We take a look at the t-test statistic. It's a 2.82. That's fairly large for a t-test value. The degrees of freedom is 17. And our p-value for this, if this had been a two-tailed test, would have been 0.012. It's a one-tailed test, so we're going to take that two-tail value and divide it in half, which comes out to be 0.006. And we'll be able to reject the null hypothesis because the 0.006 is less than or equal to alpha level of 0.05. And then finally, looking at this other scenario, the null hypothesis says that the pre-test should be less than or equal to the post-test. Quite contrary to that, the pre-test is larger. Based upon the evidence, it's 81.4 compared to 77.9. But is that a big enough difference? The t-test statistic is a 1.83. Again, somewhat promising in terms of how large it is. Degrees of freedom is 36. And the p-value for a two-tailed test is 0.076. Now remember, we're doing a one-tailed test, so we're going to divide that in half. We could just pull out a calculator and put in 0.076 and divide it in half, we get a 0.038, and that is less than or equal to our alpha level of 0.05, so we get to reject the null hypothesis.